So let's make sure I've got two examples of conversions between different volume units in this question and area units in the next one. That'll give us some idea of how these things actually do come up in practical situations. So here we've got a swimming pool, and we know the swimming pool's dimensions in feet, which is kind of standard length the standard unit you would use for that. And I want to know how many gallons will it take to fill it. And again, gallons are the kind of unit that you're going to see used by the water company, for example, when you get your water bill every month, right? So we'll get to the second part of this question in a second. So first, I need to know its volume. Well, it's a rectangular pool, it's a box. And so the volume is going to be just this expression here, 14 times 20 times 6, and that comes out to 1,680 cubic feet. Right, and I want to go to gallons, and I happen to have a conversion factor that does exactly that. So we'll start with 1,680 cubic feet, and I'm going to do cubic feet in the bottom here so they cancel. I'll do gallons here in the top because that's what I want to keep. So it's 1 cubic foot to 7.48 gallons, and you multiply this out. The cubic feet cancel. This comes out to 1,256. Excuse me, 566.4 gallons. Now I want to know how long it's going to take my garden hose to fill this thing. Okay, so I know that the hose flows at 14 gallons per minute. And really, that's almost like a conversion factor, right? To go from gallons to minutes. So I'm going to do my unit analysis with that, just like I would have done with any other conversion factor. So I'm going to do gallons in the denominator, right? Because that's what I want to go away, and I'm going to put minutes in the top because that's what I want to keep. And it's 1 minute to 14 gallons. The gallons are going to cancel. And we do what, 12,566 divided by 14. That comes out to 897.6 minutes or 14.96 hours. We're going to talk more about time conversions in an upcoming lecture. But just for now, right, there's 60 minutes an hour. So that was the conversion factor that I used. All right, so my second one here involves area. We have a house that sits on a lot that's 0.36 acres. Acres are very commonly used to denote the size of plots of land. And that's great and all, but an acre doesn't really mean much to me. Right, so I want to try to convert this into a unit that does have some meaning. So I'm going to take this to square miles and see what that looks like. Right, so I've got 0.36 acres. And let's see, I can go from acres to square feet. Then I can use this factor here to go from square feet to square miles. Right, so let's do acres in the denominator because that's what I want to go away. I'm going to put square feet up here. And there's 1 acre to 43,500 square feet. And then we'll go to square miles. So I need to have square feet here in the denominator. Let's write it the same way. Let's do feet squared, and I want to have square miles here in the numerator. And there's 1 square mile to that 27 million figure, 27,878,400. Now the acres cancel, the square feet cancel. All that's left is square miles. Ready to get your calculator out? Do the arithmetic here. This comes out to 0.0005617 square miles. Is that a reasonable unit? Well, I don't know. That's pretty small, right? It's so small that I really don't have a good grip on what that means either, unfortunately. So, what we can do is we can back this up. Instead of going to square miles, how about we go to square feet? Right? So if we just do 0.36 times 43,500, that would come out to 15,660 square feet. Okay, that makes a little more sense to me, but still, I don't have a concept in my head of how big that is. Right, so we're going to talk more about formulas for finding the area of different shapes in the next chapter when we talk about geometry, right? But just if you don't mind my jumping ahead just a little bit, let's say that this knot was a perfect square, right? Then s squared, where s is the side of the square, would equal the area. So if we take the square root of both sides, this would be 125.1. So what this tells me, the reason I did this, is if we have a square lot, 125.1 feet on a side, that is going to have this area, which was the same as our 0.36 acres. And that's a number that kind of means something to me, right? 125 feet, I understand. I can visualize how big that lot is going to be. Okay, so coming up in the next lecture, we're going to continue our discussion of different measurement systems by looking at different ways of measuring weight and mass.